if you look, we've got a test coming up at the end of next week. Now, it's just going to be a one-topic test. It's not a very long test. We probably will have some time before, like, in class to kind of review and study anyways. But the way that we split it up, all the stuff that we kind of did at the end of break with inverses and transformation graphs, we aren't testing on that. We're just going to test on the solving. So it's just kind of like a half unit. But then we'll pick back up with like some intense stuff after this. So enjoy these radical equations. They're not too bad. Kind of got a lot of examples to do today. I don't think I'm going to work every problem. I might have like, I'll do some, y'all do some. And then I have homework for you. I think it's 7 questions today. But it's really only 3 lessons. We even like put the review in the 3rd lesson because it's not, like I said, it's just not a whole lot more. And then we'll test at the end of next week. So be prepared for that. I know I've already seen a lot of emails about people being absent for various things this week and probably next. So just, if you're out, pay attention, check your email. I'll be emailing you moving forward. It's also going to be non-calculator. If you have a calculator today, that's fine. I don't know if today or maybe next class, I want to show y'all how to do some stuff in the calculator just for like in general. But this test and everything is going to be a non-calculator test. So if you have one, just try not to use it. But everything is about solving. So y'all like solving. We're getting answers. We're getting solutions. X equals, like that type of thing. It's not so much like crazy inverse equations anymore. But we're going to be, our focus today is solving 8.1. It says solving square root, but we're also doing and cube root. We're going to do both of those. So cube root equations. If you remember before break, I talked about radicals are the unit that evens are like kind of the worst. Odds are a little bit easier in this unit having to do with the domain and everything. So there's going to be some things that we got to be careful for. We got to check our work. And I got to just kind of explain all that. So just bear with me if I kind of like skip around. But it says a radical equation is an equation where your variable is underneath a radical. And again, that can be a square root, a cube root, a 4th root, a 5th root, anything like that. To solve the radical equation, there's just a couple steps. So we want to get that radical expression isolated. This is similar to what we did with inverses. Get the square root or the cube root all by itself. So move stuff over accordingly. If there's more than one radical, it can get kind of tricky. We've got a couple of examples in there, and we'll in the notes over that, and we'll go over that then. Then you're going to undo the radical by raising both sides. It says to the index, and that's just like you undo a square root by squaring, a cube root by cubing. You already kind of know that. And then you'll continue to work the problem, solving it. There could be more radicals in there. There could be more exponents. It just depends. So solve however you solve. But what you have to be careful about is that there are cases, and specifically with these even roots, with these square roots, because they have the restricted domain. When you do that undoing of the radical, the squaring of both sides, raising something to the 4th power, y'all won't do that, but you could, you run the risk of having extraneous solutions. And I know we've talked about this before with, like we had them in absolute value. I don't know, we probably had them some other times. But those are those extra solutions that sometimes they can algebraically, through your work, pop up, but then they don't actually work in the original equation. So what do? We have to check our work. So must check answers. And I know y'all love doing that. And it's really important in this. So be careful with that. So key things to know about radicals. There's 2 main things. And again, it has to do with your square roots. So I'm going to put stars by this because these are important. You cannot, so can't take an even root and even root, oh my gosh, even root of a negative number. Okay, so write that down, then let me make sure you understand what that means. And again, it's back to those evens versus odds. So you can't take the square root and get a real number of -4. Okay, and we're not going to go into imaginary land anymore. So it's those even roots, square roots, fourth roots, sixth roots, eighth roots. We can't do that with evens. So if you get to a problem and there's a negative number in there, you're going to have a situation that's not going to work. And then the other one, and this one kind of happens more, is that you can't have, and again, these are things that can happen. You can't have an even root equal to a negative number. And I'm going to put a note that says 0 is okay, because I think that happened in the homework. I was working your homework key after bowling yesterday. So if you get your isolated equation square root, again, back to evens, has to be just evens are what we worry about here, and you have square root equals -4, that can't happen, okay? Square roots, fourth roots, sixth roots, none of those can equal negative, so those solutions would be extraneous. They would be thrown out. There are potential cases where, like, you could get no solution. You can get 2 solutions. You can get one works, one doesn't, that type of thing. So we'll kind of see all those in the throughout the notes, but it's really just even roots are the tricky ones. So I feel like I have more even root practice. Odds, once you like get the flow of how these work, the only thing that really changes is you don't have to be as careful with cube roots because, again, their domains are all real numbers. You can take cube roots of negatives. You can have cube roots equal to negatives. They don't have those weird rules. So that's what we got there. So like I said, we're just going to jump through some examples, kind of go through these steps. Some of them are really quick. Some of them take a little more time. And so I might skip around and have you guys try some on your own just for practice there. So the first one, this one, the radical is already isolated, so we don't have to do that step number 1. A square root, it is even, but it's equal to a +3, so it is possible. We don't have to worry about anything weird happening here. But then I want to do step 2, raise both sides. So how do I undo a square root? What do I have to do to both sides? Square. So I'm going to square this and square this. And what's nice is that this is just a 3 on the other side, so I don't have to worry about like foiling or anything. We will get to that here pretty soon. But so when you square the square root of 2x plus 7, we kind of already did this with inverses before break. So it's just that 2x plus 7. 3 squared is 9, and then we just solve for x. So subtract the 7. 9 minus 7 is 2. Divide by 2. X equals 1. Now, I am going to make you go, especially with an even root problem, which this is an even root problem. I'll put an E right here because it's a square root. You need to go check your work, check your answer, which means you're going to take, once you listen to vocab, I just found the solution, okay? What is your solution equal to? The variable. Your solution is 1, but your solution is the variable x. So when you're checking, you're going to plug in 1, your solution for x, okay? Seems easy, but it's been a long break, and maybe we all need a refresher of some vocab. So I'm checking to see, is 2 times 1 plus 7, the square root of that, equal to 3? 2 times 1 is 2. 2 plus 7 is 9. Is the square root of 9 equal to 3? Yes or no? Check. My answer works. Okay. What if I got square root of 9 equals -3? Is that okay? No. That violates this rule. So I would have to chunk that answer. It's not working. Okay. All right. Number 2. Square root of x minus 9 equals -1. Is that minus 9 underneath the radical? No. So I need to isolate the radical first. So the first thing I need to do with this equation is what?
Square both sides.
That's not the first thing. I have to isolate the radical. Move the 9 by adding. So -1 plus 9 is, now I can square both sides. So just be careful about what order you do that. You need to make sure the radical is by itself before. And just pay attention, because again, inside a radical versus outside a radical is just kind of easy to mess it up. So just be careful there. Now I square both sides. Square, square. This is going to give me x equals 8 squared is, and then I'm done. I need to check it, but I'm done solving because there's just x equals. So my solution is x equals 64. Let's make sure that it works. The square root of 64 minus 9, is that equal to -1? What's the square root of 64? 8. 8 minus 9, is that -1? It checks out. okay? So don't just like see a negative on the other side and assume that it's not going to work. It's more about once the square root is by itself, it has to be equal to a positive. But since there was this over here, we were good, okay? Let's look at, you guys try 3. Try 3 and try 4. I think you can do 4. Just be careful on 4. Think about how to isolate. You got to do those steps in the correct order. Warning, warning. Let's talk about 4 real quick. I did 3 really fast, but hopefully we're all good there, and we see that the solution works and everything's good. And again, I mentioned this, but in case you weren't paying attention, when it comes to checking, you got to check in an equation that has the radical in it, because where these extraneous solutions, and we're going to see them in a minute, but where these extraneous solutions come from is when we do that undoing of the square root, so you got to be careful there. So either check in the original, or check in the isolated radical equation, which for this one was already isolated. What about number 4, though? That radical is not by itself. How do you do that? Yes.
Check the 6 and then divide it by 2.
Very good. Okay, so there's 2 mistakes that people sometimes make here. Here's one. I really hope that you wouldn't do this, but I'll just say it just in case anyone was thinking. You cannot like multiply anything into a radical like distributing. Okay, I hope we know that. It's kind of like, remember absolute value? I was like, oh, it's like jail. You can't go in there. This is kind of the same thing. Okay, so you can't multiply the 2 in there. Also, you cannot add these, okay, because the 2 is being multiplied by something. So you got to move it in the correct order. And that's exactly what you just said. You have to subtract over the 6, then divide by 2. Even though they put that number first, and warning, you might see that. You might see the constant being at the very front, which is kind of different than how we normally see it. You normally, I feel like, in transformation land, we would write it like this. Minus 3 plus 6. We would usually write it like that. And you would have your A, your B, your C, and your D. And I don't think y'all would get it wrong if we wrote it like this, but for some reason, if we put that in the front, there's a lot of people that tend to just not follow math rules. So step 1 is to subtract the 6. So if you haven't, or if you messed that up, let's fix it now. If you did get this, then just take a quick brain break while I work this problem out. And I'm showing all my steps that you could do some mental math here and not have to write out everything in the world, but we'll go with that. 3. And then again, when it comes to checking, you can either check in the original, or you can check in the isolated square root. I'm going to go to the original, but as long as it's a square root equation, then you could check there. 2 square root 4 times 1. 8. And that works. Any questions? So we're going to start to see some problems that could potentially give us extraneous roots. And really, kind of like with absolute value, with evens, I always check. Square roots, I'm always going to check my work no matter what. It's really good practice to check your work always. But where you have to be careful is when you have a variable on the other side of the radical. Because again, we don't know, like depending on what you get for x, that could potentially give you a positive or a negative number there. So we're still following. I got to get my radical isolated. I've got to undo the radical. In our case, we're still going to be by squaring. But let's go through 5, and then I'll let you do 6. And I do want to talk about 7 because I like the factoring on 7. But these next couple ones are kind of repetitive. But I would star these. These are ones that you're definitely going to see again, okay? So even though the radical is on this side, it doesn't really matter. I can leave it there. It's isolated. Square root of 7x plus 15 is by itself. How do I undo square root? Square both sides. But on the other side here, I do not just have one term, one number that I'm squaring. I am now squaring, what is this called? A 2-term. binomial, okay? Which means, what do you have to do? You have to FOIL, and then we're going to factor to solve it. But we have to FOIL here, okay? So we're going to end up with a quadratic equation, which we're going to need to set equal to 0, and then we're going to try to factor. If factoring doesn't work, what else can we do to solve a quadratic formula? Okay, so it's a lot, again, so much spiraling going on. So x plus 1 squared, we can FOIL that out. Do y'all need me to write that? Or can we FOIL in our head yet? Maybe day 1 we'll actually write it out because it's been a couple weeks off. So that's going to give us what? X squared plus 2x plus 1. 1 times 1. Equals 7x plus 15. No, it's fine. I'm surprised I haven't made more mistakes yet. You should have seen me first period. So I have this equation left over. No more radicals, so I'm good. But again, whenever I see an x squared, I'm always thinking set equal to 0. Keep the squared term positive, okay? Please. That really messed some of y'all up in the last test that we took, was factoring with the negative a value. Don't. Move it to where the a value is positive. So move this over, move this over. So that'll give us x squared. 2x minus 7x will be negative 5x. 1 minus 15 is negative 14. Yes? Is this easy factoring? How do you know? Because it's 1x squared. The a value is 1, which means you don't have to group. So you're welcome, okay? But we still have to number puzzle. What are two numbers that multiply to be negative 14 and add to be negative 5? Easy factoring. Let me draw my little number puzzle. Negative 14, negative 5, which I'll say negative 7, positive 2. So then what's my factored form? Minus 7 equals 0. So that's my factored form. What are my solutions? My potential solutions. X equals positive 7, x equals negative 2. I had a few. It was a very small number, but the last test that we had in easy factoring, I did have some people that were like flipping the signs too early. You do the number puzzle, those go directly into the factors, and then you flip the sign when you're solving there. But again, what we got to be careful about here is we have to check these, okay? Especially when you've got a variable on this side of the square root. You got to be careful with that. So if we put 7 in as our solution, this would give us 7 plus 1. Is that equal to the square root of 7 times 7 plus 15? And again, this is a check. This is like, I'm going to do some mental math and make sure that it works out. 7 plus 1 is 8. That's positive, so this is promising. If this guy was negative, I would immediately throw this out because the square root can't equal a negative. But let's just check the math here. 7 times 7 is 49. 49 plus 15 is 8 equal to the square root of 64? So this solution is valid. Okay, so I would box that. And y'all know that when I grade this, I want to see you actually solve for both, and I want to see you be able to declare like this one works, this one doesn't. But I still need to see both those numbers. Now, what happens when I check negative 2? Negative 2 plus 1, is that equal to the square root of 7 times negative 2 plus 15? What's negative 2 plus 1? Can a square root ever equal a negative number?
9.
No. So should I even keep going on that side? No. I would just really make sure it's this side that's okay. So this is not going to work, which means is this a solution? No. This guy is, you can just exit out like I did, but technically, if you want to have good math vocabulary, that's an extraneous solution. Again, it's one of those that kind of popped up when we did the squaring of both sides. Because remember, we turned it into a quadratic equation, and how many branches do a parabola have? I'm making a parabola right here in case you forgot what that looks like.
Oh, 2.
There's 2. But a square root only has 1 branch. So when we change the problem and make it one of these, we kind of run the risk of getting an extra answer there. And that's where those extraneous go from there. Okay? So try 6 and 7. I want to just see if y'all can do 7. But we will talk about 7. 6 and 7... yeah, and then we got a couple more square roots for that. Okay, so here's 6 real quick, just so you can check your work. On number 6, again, I got 2 solutions algebraically, but only one that worked. So one of them was extraneous. Is it possible for them both to be extraneous? Yes. It's possible to get a no solution, okay? Is it possible for both of them to work? Yeah, it's possible for both of them to work. So it truly just, the algebra is going to work the same with these types of problems. You should be getting to. It's just really up to you. You got to look at what happens, what the radical is going to be equal to. As long as the radical is equal to a positive number or 0. I think there was one on your homework, and when you plug it back in, you get a 0 right here, and that's okay. A square root can equal 0, so that solution would be valid. It's only when you get a negative equal to a square root, okay? So 2 could work, 1 could work, none could work. Possibilities there. I kind of started on number 7 because I wanted to go over this, and as we get closer and closer to unit, I don't know what number it will be, whatever one's after this, we have to be so good at all the types of factoring. And this is something that I feel like I complained about a lot in our last couple of units is how do you factor that? What do you do? Yes.
Divided by x.
Okay, so it doesn't go away though.
Take x out as a factor.
Very good. That's how I prefer to hear it. A GCF of x, and you just divide each term by x. So I would need to write this, again, when you get to a binomial, there's kind of 2 options when it comes to factoring binomials. The first option is checking for, well, really, you should always check for a GCF, but there's an option that it could just be take a GCF out and you're done. The other option is my favorite factoring pattern, which is difference of squares. So you're going to start to see these. You got to know the difference between. This one's kind of tricky. Why is this not a difference of squares? Do you remember difference of squares? Because the second one has an x on it. Okay, if I took this x out, what is that? How do you factor that? X squared minus 4. That's a difference of squares. We need to know the difference. That would be x plus 2, x minus 2. But it's there, so I factor it like this. 0 equals x times x minus 4. So what are your possible solutions?
X equals 0, x equals positive.
Thank you. X equals 0 if you take out a GCF that has a variable in it. It doesn't matter the coefficient of the variable. It doesn't even matter the exponent of the variable. It's going to give you a solution at 0, and you have to know that, okay? And this is going to give us one at 4, okay? Now, if I plug both of those back in, square root of 10 times 0 plus 9, is that equal to 0 plus 3? What's 0 plus 3? 3. 10 times 0 plus 9 is square root of 9. Does this solution work? So 0 is a valid solution. Does 4 work? I think it does. And you can do some of that mental math in your head. Like if you saw, okay, 10 times 4, 40. 40 plus 9 is 49. 4 plus 3 is 7. If you just show like that, that's fine too. You don't have to show every single step with that, especially when the checking. So 8 is really actually pretty easy. 9 is going to get a little crazy. So we'll do 8 and 9 together. Y'all can try 10, and then we'll take a little brain break, and we'll talk about cube roots, and then hopefully you have time to get all your homework done. I'm still going to be doing my homework checks and assigning academic lunches. I haven't passed out the homework yet. I need to find it. It's somewhere in here. I know it's somewhere. I just don't know where. Okay, so if you have a radical on both sides. So let's talk about what happens with that here, because depending on what's inside the radical, they could be really easy. Like number 8, I do have 2 radicals, but is there anything happening outside of either of them? No. So this actually is a pretty easy problem. So since there's nothing happening outside the radicals on either side, all I have to do is just undo those radicals by doing what? Squaring, which we already know how to do. And then that's just going to leave me with what's under the radicals, and those are going to equal each other. That's the case, and like I said, as long as there's no extra numbers being added or subtracted or even multiplied in the front or behind the radicals, just square both sides, go from there. So this is just a really easy algebra 1. Subtract this over. This is 2x. Add this over. This is 8. Divide. X equals 4. Okay, you should still check because these are square root equations, and we just want to make sure that we're good. 4 plus 6 is 10. Square root of 3 times 4 is 12. Minus 2 is 10. Square root of 10 equals square root of 10. Do y'all see how quick I just checked that? I'm okay if you do that. Okay, try to make it easier on yourself. So that solution does work here. Now, look at number 9. There are 2 radicals in there. But what's on the right-hand side? A 9. Okay, if that was a 0, Well, actually, that still wouldn't work because that would have to be minus x. So these problems, and then this one over here, there's two radicals, but then there's a minus 2 floating out here. These are going to get more complicated. And you've got one on your homework. I'm going to help you guys with that one because just the way it's set up algebraically, there's something different we're going to solve in the homework problems than we do with these. But here's what I suggest, okay? There's more than one way that you can do this problem. There's a lot of times that happens in math. But what I think is easier with these is still to kind of continue on your, I'm going to isolate a radical plan, okay? So I would get the more complicated radical, which I just boxed, square root of x minus 9. I would try to get that by itself, okay? Still try to isolate, if you will, even though there's going to be a radical on the other side. I think this way is going to be way easier than the other way. And this problem is really not even that easy, okay? So how do I move this square root x to get this thing I boxed all by itself? What am I going to do? Subtract it over, okay? So I'm going to have the square root of x minus 9 is equal to 9 minus the square root of x, okay? Not the only way you can do this, but again, I think it's easier. And I'm trying to save you a headache. All right, so get one of those radicals all by themselves. So now I can kind of think, okay, if I wanted to undo this radical, this square root right here, what would I do to both sides? I square both sides. And on the left-hand side, what is that going to give me on the left? X minus 9, okay? On the right, though, you have two terms. So you have a binomial squared, which means you have to do what process? Foil, okay? This is where it's going to get not quite as pretty. I'm going to write this out to the side. I'm going to try to write kind of small so we have room to do the other problem. But I am going to actually FOIL this out. So I have 9 minus square root x times 9 minus square root x. Okay? When I FOIL that, 9 times 9 is, okay, 9 times negative square root x. That is negative 9 square root x. Okay? You just multiplied it. Okay? Then I have negative square root x times 9. Think of the negative as like a negative 1. So you're multiplying negative 1 times 9 is negative 9 again, and just bring the square root x. What's square root, negative square root x times negative square root x? No.
What's x?
It's x. We don't like that.
Wait, can you walk through that one more time? Like,
Mhm. Which part? All the FOIL or just this part?
the whole thing.
Okay, so I did 9 times 9. Shh, quiet. 9 times 9 is 81. We okay with that? This is probably the only one we're okay with. Okay? This is like 9 times negative 1 square root x. And so that's where I got the negative 9 in front. Because 9 times negative 1 is negative 9.
Right.
And then I just square root x. Because that's like, I can't do anything with that.
Right, and then you do the next one.
Next one will be the same. Now, square root x times square root x. When you, didn't y'all do that in geometry ever? When you were like rationalizing a denominator? And you multiply. We block geometry from our brain. So, when you multiply, okay, it doesn't matter. Don't worry about geometry. Don't worry about geometry. When you multiply two radicals and they have the exact same thing underneath, it basically unravels the radical and you're just left with. It's like the same idea of square root of x minus 9 squared. This is like saying the square root of x squared. So they undo each other.
Okay.
And then that's how this one just becomes just x. Okay? And that's going to equal x. Okay? Maybe if I wrote it like this, that would kind of help you see why that works. Okay? Okay, so now we still can simplify this a little bit because these two guys right here, those are like terms. They both have a square root of x. So that means I just need to add up those two coefficients. So 81 is going to drop. Negative 9 minus 9 is
Negative 18 square x.
square root x
square root of.
plus x. Okay? That is the trinomial when you FOIL this out. So I'm going to put this trinomial over here. 81 minus, this is honestly the worst part, is FOILing that out. But it sure makes it a heck of a lot easier if that second radical is like really simple. It would make it even worse if it wasn't. So I put that right here. Okay? So now you kind of have to go back to, don't go back, I'm going to show you just real quick. But remember, we said if there's more, if there's still a radical in the equation, you kind of start over your steps. So I have a radical in the equation still, which means I now need to like go back to step 1. I move everything over to get this square root of x by itself. So what do I have to do with the 81? Subtract it over. What do I have to do with the positive x? Subtract it over, okay? So when I do that, let me write this in a different color. I'm going to draw a line too. This is very Algebra 1 style. But just so you're kind of aware of what I'm doing. And that's going to move this term and this term over. Now, convenient for us, what happens over here? X minus x. Where is that going to go? That's going to cancel out as well. Negative 9 minus 81 will not. That's going to give us negative 90 equals, what are we equal to? Negative 18 root x. Okay? So I will warn you. And then it's not too bad to solve from here. I just want to stop at this step right here, though, because the way that I do this in the notes is not the way that I'm going to do the one like this on the homework. And I'll show you why. We're going to do it a different way. It's just because of what was like left over there. But for this problem, since I just have a negative 90 right here, I can move over that negative 18. I can truly isolate this radical by doing what? How do I undo the negative 18? Well, so I'm trying to isolate that. That is one way you could do it. I'm not going to do it that right now, though, because we don't have a calculator. Okay? So I can divide both sides by negative 18. Negative 18 here. Okay? This is convenient because 90 is divisible by 18. If it wasn't, that's okay. Fractions are still numbers. You can deal with them. I think this one gets a fraction. But what is that? 5? Positive, because it's a negative over a negative, equals square root x. Okay? Also want to stop right here. We're almost done. Can a square root equal a positive 5? Is that possible?
9.
Yes.
C.
What if it was a negative 5 right here? Not possible. So you kind of, when you get here, and we'll see more problems like that, but just kind of like give you a little bit of a reminder of where we're going. You still got to keep checking that square root, make sure they're equal to positives. How do we undo the square root? Square both sides. Square both sides. And so what is x equal to? 25. Yeah, it doesn't take that long. But yes, you do. You would do square root of, we'll just kind of do it quick. 25 minus 9 is what? 16 plus square root of 25. Is that equal to 9? What's the square root of 16? What's the square root of 25? 4 plus 5 is? Was it that bad to check? No. Okay. All right, I want you to try number 10. How to do it? I just went back to the original problem. I just plugged in. Yeah. I always check the original problem, typically. Okay, this one, number 10. I want y'all to try this, okay? You are going to have to do a FOIL with a situation like this. This one, though, I wouldn't move anything over. I already have one of my radicals by itself, so I would just go straight into the squaring. The only thing, this problem is actually easier. The only thing that is a little bit weird about this is that your answer is a fraction. That's the only thing, okay? So try 10, and then we're going to get into cubes, which are not bad. So you do, again, you didn't have to move anything because this radical was already by itself. So I just went straight into squaring both sides. I did have to FOIL this. I wrote that over here. It's pretty similar to what we did on the other side as far as what I get for my answer. So I got this 3-term thing over here. And then I was equal to x minus 10. I was now focusing on getting the square root x all by itself. So I moved the x over. Everything simplified to 0. There, that was great. I moved the 4 over. That simplified to negative 14. Then I got rid of the negative 4 by dividing. Now here's the thing. Negative 14 divided by 4 is not a nice, pretty whole number. When you don't have a calculator, which you will not on this test, I would always say just reduce the fraction. I wouldn't, personally, I don't like decimals as much, so I would try to reduce that fraction as much as possible. It is going to be easier if you reduce it, okay, especially without a calculator. So that reduces to positive 7 over 2. And again, it's positive, so that's good. If it was a negative, which I accidentally wrote down, but if it was a negative, we wouldn't be able to do anything. So now I have to undo this square root, which means I square, and this is the question I think several of you were asking, how do I square that? You square the numerator, and then you square the denominator. So this is going to give me x equals 7 squared is 2 squared is 4. Okay? And I will just save you the trouble, it works. And so that would be your answer. So I don't want you to freak out if you possibly get solutions that are fractions. It is possible for that to happen, and it's great. Just move on, okay? All right, let's flip over. I'm not going to do all these problems with you. I just want to talk about a few of them here. First thing, number 6 was not supposed to be on that page because this is a square root, and this is supposed to be cube root equations, so you got enough practice on the homework for that, so we can ditch that. Also, I think we're going to need more room on number 5. Here's the thing that ultimately the process of these problems are very much the same. You're isolating your cube root. You're undoing a cube root. How? That's going to be different. How do you undo a cube root? You cube both sides, okay? So now you're multiplying something 3 times. Woohoo. But what is nice about these, and I'm going to kind of write this at the top, is that these are odds. Remember I said odds are easy. Their domains are all real numbers. There's no restrictions. So that means that a cube root of a negative number is okay. You can do that. Is okay. You're able to do that, okay? The cube root of a negative number will be a negative. Also, what is okay is to have a cube root of something equal to a negative number. That is also okay. So if you isolate, or if you go back and check and you have the cubed root of something equals negative, that's okay because it's odd and that's possible. It's always important to check your work just to make sure you didn't make like arithmetic mistakes. However, you shouldn't be getting extraneous solutions with these. You shouldn't be getting stuff that algebraically doesn't check out. If you did get something that didn't make sense, you made a mistake in your algebra because these all should check out. So go ahead and try the first 4. I do want to talk about 5, but I'm going to let you kind of work on 1 through 4, and then we'll reconvene. I need to find y'all's homework papers. I'll work on that real quick. So 1 through 4, and then I'm going to do 5 with you. Ready, set, go. I will get, I'll say the answers real quick to these in case you have finished them, just so you can check. I worked out number 1. I'll get all the work on my key on Canvas. Number 2 is x equals 32. Number 3 is x equals 62. Number 4 is x equals 2. And again, I'll get all these worked out just in case you are checking and want to know if you're on the right track. And again, checking is encouraged. However, you shouldn't get extraneous solutions. So algebraically, as long as you've done your math right, the answers, the solutions you get should work. Okay? Number 5, though, I just wanted to at least like start you on number 5. The radical's isolated. Okay? But on this side, we're equal to x minus 1. So the first thing would be, how do I undo the cube root? Y'all already know. What do I do to both sides? Cube both sides. Now, here's the thing over here. This is a binomial. I keep going back to. There's more than just one term here. Which means I have to multiply x minus 1 times itself, not just twice, but 3 times. So my suggestion would be to FOIL the first two, and you'll get a trinomial. And then you're going to multiply the trinomial times the binomial, and you'll get a longer polynomial. But what ends up happening is that a lot of stuff is going to like cancel out actually on this problem. And I only got one solution that did work. But even though you have an x over here, because this is an odd root, no matter what that number is, it can be negative, it can be positive, it can be 0. So like, again, the solutions that you get should work. So start working on that. I'm going to pass out your homework. I need to talk about a homework problem, but we have time. And then I'm also going to work on this answer keys so that way you can have at least the work to check in case you didn't get an answer that I did. So, okay. I circled, because some of y'all get confused, I circled 8.1 is questions 1 through 7, so I drew a line. This is what you're responsible for by next class. Okay, 8.2 has a lot of problems, but I promise you they are very, very quick, so don't freak out about that. Then here's the other thing, no freaking out. The other thing is 8.3 has a lot of problems. 8.3 is also like the review, okay? So like there's not going to be a separate review sheet. It's going to be in 2 days, so not next class, but the next class I'm going to be checking these problems. Make sure you have that done. And then 8.3 we'll finish up our last little bit of a lesson, and then you'll just work on all this solving, okay? There is one thing. Hold on. Yes.
You said both 8.1 and 0.2 is next class?
No.
Next class.
I will be doing a homework check on Tuesday, and then the other review 8.3 problems are due here. All right. Right. Okay. It's just really short. Okay, listen. I am not done working an answer key for this whole thing, but I'm through question 7, I believe. I did notice this, though. Number 4, why we're not... Okay, hold on. Number 4 on 8.3. Apparently the numbers started over. This is not my doing. Does everyone know what I'm talking about? 8.3, number 4, where it says blah, 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 equals 1. That's not supposed to be 1. That's supposed to be a 15. So while it's fresh on my mind, because I just noticed it during power lunch, write that in, okay? I will let you know if I catch any other mistakes. Haven't, and I'm all the way through this 7. But I did want to show you number 5 right here, real quick. Go if you can't wait. Okay. This is one that I said, we did those ones in the notes where there was 2 radicals and the foiling was kind of weird, but here's what happens on this. I'm going to flip it over on the back and write this in because I did solve it slightly differently than how we would have, okay? So someone read it to me real quick. What is it? Square root 3x plus 5. 6x plus 34. You honestly might want to sit down and actually write this. It's just a suggestion. Okay. Again, I don't have I have this radical isolated, so I'm good. Okay. To start squaring, I'm doing a homework problem with you, so I probably listen. Okay. This is number 5. This is 8.1, number 5. Okay. Find somewhere to write it down. I don't want you to get confused because if you try to solve it the way I did in class, it would get really, really messy. So I just wanted to show this to you. So it's a freebie, okay? So this will be 6x plus 34 on the right. That's the easy side. Over here, we've got a FOIL, square root of 3x plus 5. So I'm going to do that real quick. Square root of 3x plus 5 times square root 3x plus 5. Square root of 3x times square root of 3x is 3x. Then I've got 5 square root 3x plus 5 square root 3x plus 5 times 5 is, and then I combine. This is not the part that's different, so I am going through it kind of fast because we've already talked about this, and if you don't get this, come see me later. 3x plus 10 root 3x plus 25 right here. Okay? So now what I'm trying to do is get this square root 3x isolated, get this other radical isolated. Same step I did in the notes, okay? So I need to move the 3x over. Here's where things get a little bit different than they were in the notes. Are my x's going to cancel out? No. Okay? So I end up with 10 root 3x equals 3x plus 9. Now, in the notes, I then isolated that radical by dividing by 10, but can 3x over 10 and 9 over 10, do those give you nice, pretty whole numbers? So here's something that you can do in a situation where it's like you have an x left over, there's going to be crazy fractions. Simple fractions aren't bad, but these are going to get kind of crazy because I would have to end up foiling this too because it's 2 terms. So technically, mathematically speaking, I can square both sides at this step. This is not really something that we normally would do, but it is going to make this problem easier. So I just want to show you that it's an option. But only at this step can I do it. So the way that I deal with this is I square the 10. So what's 10 squared? 100. And then I square the 3x, and what's that? Square the square root of 3x, so that is 3x. So I have this going on, which is 300x, and then I would have to FOIL this over here. And y'all can take it from there. What will happen is you'll end up with a trinomial over here. You set it equal to 0. The numbers get fairly big, but there is a GCF that your factoring is doable without a calculator. You do get 2 solutions on that, okay? So that is your hint on number 5. It is mostly worked out for you. You just have to finish it. Everything else, I don't think the numbers get super crazy. This is the worst, but like it's like 300 minus 54 or something, so it's not that bad. But everything else should be good. And I am going to have an answer key with just the answers on it. I don't have that yet. I have all the work. I just don't have the answers to let you look at yet. So, anyways, that's what we're doing now. Work, work, work. You got some time.